Now here the question is, consider a complex valued function fz, and it is given by 1 upon z minus iota. Now it says locus of point fz as z lies on real axis is. Now if z is real, say z is x, then we can write fz as 1 upon x minus iota, and this is equal to say u plus iota v. Now we can write this as x plus iota upon x square plus 1, it is equal to u plus iota v. Now u is x upon x square plus 1 and v is 1 upon x square plus 1. So we can write x as u upon v. Now we put the value of x here, we can write v equals 1 upon u square upon v square plus 1. So it will be u square plus v square minus v equals 0, which is x square plus y square minus y equals 0, which is equation of a circle. So answer to this question 42 is this option B. Now question number 43 is, if FA, FB and FC are vertices of a triangle, ABC belongs to R minus 0, then area of this triangle is. Now we know that if ABC they are real, then FA, FB and FC they lie on this circle. Now for this circle, center is at 0, 1 by 2 and radius is also 1 by 2. So we'll have this circle, its center at 0, 1 by 2 and radius equals 1 by 2. Now we need to find maximum area of this triangle, which can be inscribed in this circle. Now we know that in a circle, area of triangle is maximum when the triangle is an equilateral triangle. So this triangle, it must be an equilateral triangle. So we need to find area of this triangle. It will be 3 times, and then area of these 3 triangles will be 1 by 2 into 1 by 2 into 1 by 2. So this maximum area will be 3 root 3 by 16, and that's your option C. And question number 44 is, if FA, FB, FC and FD where A, B, C, D are R minus 0 vertices of a square, then we need to find area of this square. Now again, since A, B, C, D are real, this square will lie inside this circle. So we have this circle and then we have a square which is inscribed in this circle. Now let the length be L. So we know that root 2L, it must be equal to length of diameter, which is 1. So value of L is 1 by root 2. Then area of square will be simply L square and L will be 1 by 2. Here this square is always constant and is independent of A, B and C. That's your options C and D. So this area, it must be 1 by 2.